So day 2 of transformations, something a lot of kids do struggle with. We have just a basic transformation. Graph of f of x is shown. Draw the graph of g of x, which is negative 2 f's of 1/2 x minus 1 plus 2. Do remember your order on these things. The order is Bahak. That's the order we do it. Bahak. B has a value of 1/2, and B is inside parentheses, and it's always opposite of what you think it's going to do. It is not what we call a horizontal compression. It's actually a horizontal stretch. The reason B is backwards, think about maybe something with a zero product property, like 2x minus 1 times 4x plus 2. Set it equal to 0. If you do apply the zero product property, you take each factor and set it equal to 0. And what ends up happening is, of course, we have a sign change there. 2x is 1. And then we divide by 2, and x is 1/2. It didn't double x. It cut it in half. This one would be similar. We'd set that equal to 0. We would take away 2 from both sides, and we divide by 4. So we have the sign change, and we have division happening. It works opposite the way you think. And again, this is going to be a horizontal stretch. And what it does is it doubles the x values. All right, H, and I'm talking about lettering here. I'm assuming you remember things. That's a big assumption to make, isn't it? So if I do a lineup process here, we see that H is 1. It's not negative 1, change sign. That means we're going to shift right 1. A is negative 2. Okay. This is going to be two things. It's going to be a vertical reflection, and the 2 is going to double the y values. So we also have a vertical stretch. Now, as far as the math, we simply multiply the y values by negative 2. And then the last thing we have here is k, and k is 2. That's going to be a shift up 2. And we have to do this in order, so, a lot of fun here. First thing we're going to do is B. We're going to take our x values and we're going to double them. So here we have an x value of negative 6. And if we double them, we'd be at negative 12, which is actually off the grid over here somewhere. Here we have an x value of negative 4. If we double it, we'll have an x value of negative 8. Switch over to red. Here we have an x value of 0. If we double it, we'll still be an x value of 0. X value of 2 becomes an x value of 4. And an x value of 4 becomes an x value of 8. So let's see here. Let's connect these dots, and you'll see we have done what's called a horizontal stretch. It's also essentially the same as a vertical compression. You push down on it, made it longer. And again, it's Bahak. So the next thing to do is shift right 1. It's going to put this guy here, 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 and here. Next up is A. A, we multiply the y values by negative 2. This y value is at negative 3, and if we multiply it by negative 2, we'd be at positive 3. This y value is 0. If you double 0, you're still 0. This y value is negative 2. If you double it, you'll be... Oop, I only multiplied the negative. Let's forgive Milbrath for a second. This is negative 3. If you multiply it by negative 2, you would be at positive 6. Which puts you about right there. If you double a 0, you're still 0. If we multiply this y value of negative 2 by negative 2, we'll be at positive 4. If we multiply this y value of 1 by negative 2, we will be at negative 2. And the same here. So you can see that we have done the vertical reflection, and we've also done the vertical stretch, because now it's twice as tall. And the last thing is that the k value is 2. We're going to shift this whole thing up 2. So rise 2, rise 2, rise 2, rise 2, rise 2. You'll notice I did this step by step. If you try to do this all at once, the odds of you being right are strongly against you. They are. I mean, you just do it piece by piece. There's nothing more I can say about that. Does it take a little time? Sure, it does. Most things do. A hard lesson to learn in life is not to rush. It really is. All right, given f(x) is shown, find g of x, which is 1/2 of f times 2 times x plus 2 minus 3. So let's do a lineup process with our form, and let's pick out the things that we're going to pull from it. We're going to line it up with a f's of b times x minus h plus k, and pick out our stuff. And again, your order here, bahawk. It's like hawking a loogie, I guess. I don't know. b is 2, which means we divide the x values by 2. We don't multiply, we divide. H looks like -2. That's going to be a shift left 2. A is 1/2, which means we cut the y values in half. And then k is -3. Shift down 3. Not necessarily different stuff. Alright, so the first thing we have to do is b, and we're supposed to divide our x values by 2, so we have an x value of -6, cut it in half, -3. We have an x value of -3, if you cut it in half, -1.5. X value of 0, cut in half, still 0. X value of 2, cut in half is 1. X value of 4, cut in half is 2. And there's another one over here. X value of 8, cut in half is 4. There we go. Alright, B is done. Moving on to H, -2, shift left 2 units. I'm just going to move this one down here. You don't have to move all the points, just enough to draw what you're drawing. A is 1/2, cut the y values in half. So we do have an odd one here, it's 5. If you cut it in half, you're at 2.5. If you cut a 4 in half, you're at 2. If you cut a 4 in half, you're at 2 and 2. That was your vertical compression. And then K is -3, which is a shift down 3 units. So put me about right there, 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 and there. And that ugly mess, with the red function being the last one, is the transformation. And boy, that's a hideous, ugly mess, isn't it? Yes, it is. It's disgusting. Alright. Given f of x is x cubed minus 1, find g of x, which is -f of twice x plus 2 minus 5. And this is just as hard as you think it is. Alright, now, do things in order. Remember, your order is bahawk. That's kind of a big deal. There's only one real place we're going to have an issue here. It's that -f. So anyways, we can kind of do b and h together. They're inside. So I'm going to do b and h. G of x would be, we're going to have to open up a set of parentheses, 2 times x plus 2, and there is a cube, so cubed. Now, we already have a -1. That doesn't go anywhere, okay? The next thing is a, okay, and a is -1. Now, here's where it gets kind of fun. See, it says negative function. You have to negate everything you have. So g of x is going to be a negative parentheses 2 times x plus 2, quantity cubed minus 1. And that's where it gets interesting. If there's more than just a parent function, you have to actually do some distribution there. So distributing this, we would get negative parentheses 2 times x plus 2 to the third power, and then not -1, +1. That negates the function. That does the reflection that was necessary. And now we'll do k. K is -5, so all we have to do is take away 5 from the back of the bus. That's it. I'm looking at this function right here. I'm missing a set of parentheses. And if I do 1 take away 5, I'm simply negative 4. So is that right, Milbrath? Did that do everything it was supposed to do? Should have. No, we'll see. We got another one of these, and this is how most of them are. They don't try to make things too terribly complex. Notice how it doesn't say plus or minus something at the end. I don't think the state would put a plus or minus at the end. I really don't. So this one will be pretty easy. Let's see here. We got to do the inside first. Remember, we got to do b first. There's already a 2 times x minus 3 minus 4. So I've inserted my 2. Negative 3 take away 4 is negative 7. Close, close. Power here is the 1/2, which is the square root symbol. And what I just did there is I did b and h. It's okay to do b and h basically at the same time. They're both horizontal. Now I'm going to attack that a value, which is 3. 2 times 3 is going to be 6. And there you go. Like, that's how hard that was. It ain't that hard. Alright, moving forward. Describe what transformations have occurred. Given f of x is x cubed and g of x is 2 times f of negative 3 times x minus 2 plus 5. And this is just a verbal description of where things are. It's not too terribly rough. A times f of x minus, AFs of b times x minus h plus k. It's a lineup process. So a is 2. We have a vertical stretch. Factor of 2. Easy peasy lemon squeezy. B is negative 3. We have a horizontal reflection. There's a negative symbol in there. I hadn't really done any of that. And we also have a horizontal, not stretch, compression. Factor of 1/3, which means it's 1/3 as wide as it was originally. Remember, we do opposites. Inside we have that h is 2. That is a shift. Let's use the word translation. Translate right 2. And then we have k is 5, which means we translate up 5. And last one. Identify the transformations that turn f of x, which is solid, into g of x, which is dashed. Write your entry using the following form. So let's pick on some points here. Like, let's figure out a coordinate pair of points here. This point right here looks to be at negative 6, 2. And this point right here looks to be at 3, 0. Sorry, negative 3, 0. So I can kind of tell that the x values were cut in half. That means that b is 2. I also noticed that the graph fell. Well, the graph also, not only does it look like the x values are cut in half, the graph doesn't look the same height. Let's see, what else we got up here? So maybe I don't need to be worrying about that. Let's see here. This is going to be 0, 7. And this corresponding point is down here. Which is at 0, negative 5. Now, how on earth did that happen? Well, what if a reflection was done and then we shifted it up? So what if there was a reflection that was done and then I added 2? That would probably do it, wouldn't it? So there we go. That's the other things that happened. The graph was reflected. Tells me that a is negative 1. And there is a vertical shift up 2. So k is 2. So here's what actually happened. Negative, because a is negative 1. F sub b was 2. We did not shift it right or left, did we? No. So just 2x on the inside. No need for parentheses. And then we added 2. And there you go. I'm sure that you all enjoyed that section. Thankfully, it's our last day of talking about transformations, at least me teaching them. I'll keep them around all year, but more or less the last day of teaching transformations.